Hello everybody and welcome back to the second tutorial of coding our malware. So what we did in the previous one is we only defined this function as well as imported some of the needed libraries for this program. Right now what we are going to do is we are going to create the API entry for the actual Windows, but before we do that, let's create some of the global variables such as integer socket, which we are going to use in two different functions. We didn't really code it in the actual outer program. In server, we only coded it in the actual main function because we only used it in the main function. But in this actual tutorial, in this actual program, we are going to need more functions besides main function, and therefore we need to code this to be an actual global variable so it can be used by multiple functions, as well as structure sock addr underscore in server address. So server addr. Make sure that you add dot and comma behind each one of them. And right now let's go into our main function, which is going to be the API entry Windows main. So it is coded a little bit different and it has a little bit more harsh syntax than the actual main function in Linux that we used in server. So just follow what I'm typing right here. Integer API capital entry capital, so one word, and then we are going to call it the Windows main. And then this actual function takes multiple parameters such as h instance, and then lower h, and then capital I instance. And if you're wondering, well, let me just code it right here first, and then I will show you what this function is. So this is the second parameter, h instance, h prev, and then the third parameter is lpstr, and then lpcmd line. So make sure that you code everything the same way I do. And the last parameter for this win main function is going to be the integer of the ncmd show. Okay, so this is the actual parameters that this function takes in. So let's go to the actual Google Chrome and let's type, for example, h instance c. Let's go right here, h instance. If you're wondering about anything, as I said, even in the C program, so here you can see the actual same function that we coded right here, just instead of lpstr, we have pwstr. And you can see the four parameters are right here. So anything that you actually do not understand, simply just Google search and you will understand it a little bit better. So right here you have h instance is something called a handle to an instance or handle to a module. The operating system uses this value to identify the executable exe when it is loaded in memory. The instance handle is needed for certain Windows functions, for example to load icons or bitmaps. The next one, which is hprev instance, has no meaning. It was used in 16-bit Windows but is now always 0. The pcmd line contains the command line arguments as Unicode string. The ncmd show is a flag that says whether the main application window will be minimized, maximized, or shown normally. So the main application window will be minimized, maximized, or shown normally, and in our case we don't really want the actual window to show at all because we're creating a malware. We don't want our actual window to pop up once we execute once the target executes the malware. Therefore we are going to set the actual window to open just for a brief second before actually closing, and it will appear to a target as if the program didn't open at all. So right now that we coded the actual parameters, let's open the brackets for a function right here, and let's start off with creating the handle, and let's start off with creating something called hwnd stealth. And once again, for any of you wondering, the Microsoft has a good explanation for every actual thing in C, every type of an actual variable, every type of API entry functions. So you can find everything explained in the Windows Microsoft forums. As you can see right here, you simply just search what you need, hwndc, and you will get an explanation on some of these websites. So I will not be explaining any of these because this actual section will be around 10 hours long. Therefore, I assume that you are going to search everything you don't understand in the Google Chrome. So the next line that we're going to use is we are going to allocate the console, which we can use using this function right here. So simply just allocate the console and create a stealth, which is a variable that we created right here, to be equal to find window A and then console window class, and the second parameter will be null. And if you go to the Google Chrome once again and you find the actual function that we're using, which is find window A function, which is stored in the winuser.h, I believe, it retrieves a handle to the top level window whose class name and window name match the specified strings. This function does not search child windows. This function does not perform a case sensitive search, and you will have the syntax as well as the parameters explained right here. The return value, we can see that the type of the actual value is H, W, and D. If the function succeeds, the return value is a handle to the window, which stands for this right here, that has the specified class name and window name. If the function fails, the return value is 0. So make sure to read all of that. For now on, we are going to simply just use show window, and now use the stealth once again, and the second parameter will be set to 0. So what we are doing right here is, as I said previously, we are making sure that not a single actual application, not a single command prompt opens up once we start or once the target executes a program. We want to make sure that it looks like the program didn't even start. And in the background, our reverse shell, backdoor or malware, however you want to call it, will be executed, and we will have a connection to our target. Okay? So right here inside the class, the next thing that we need to do is we need to perform the same thing we did in our server. So we're going to call the structure sock address underscore in, and then we're going to use server or serve addr as the actual structure that we need. The next thing that we're going to need is a port or a variable that is going to be equal to the server port. So unsigned, it is going to be a variable type of unsigned short. So unsigned short, and then server port. Okay, so these two variables we're going to need right here. We're also going to need the actual server IP, so we will set that to be a pointer to the server IP. And another thing that we are going to need for the connection of socket in Windows is a variable type called WSA data, and we're going to call it simply just WSA and then data right here. The WSA data you will see just in case, let me just get right to it. It goes right after the actual coding of server IP and server port. So before we do that, let's start server IP to be equal to the IP address of our Cal Linux machine, which is in my case 192.168.1.7, and the server port will be equal to 50,004. Okay, so now we come to the actual WSA data. So if you have a function, as it says right here, it's really hard to explain, but as it says right here, the WSA startup function initiates use of WinSock DLL by a process. Now, we have the return value right here, and the return value is actually important to see whether it worked or didn't. They created the WSA data variable as we did, and now they're going to call the WSA startup function right here. Yeah, and if the return value is not equal to 0, then the WSA startup failed with an error, and then they print an error. So we're going to perform the same thing right here, just we're going to do it a little bit differently. So if, and then in between the brackets, we're going to call the WSA startup function, and we're going to use make word 2.0 at the actual location. Let me just find the comma right here from the WSA data. And if that is not equal to 0, as we did in the actual example, so if it is not equal to 0, that means that we run into an error, and we're not really going to print that error. There is no point. We're simply just going to exit with 1. So we're going to exit if this actual function does not work. If it does work, then we can proceed to creating our socket object and connecting back to the server. So if socket equals socket and then af underscore inet, comma sock underscore stream, comma 0 to be larger than 0, then that means that we actually perform we're going to create the socket object just as we did in our server, and then we're going to use the memory set function, but let's just use both of these functions in our program so we have the variety. The memory set is the same thing as B0, just B0 can only be used in Linux programs, as I already said before. We're going to use memset right here, and in our shell function we're going to use the B0. So what we're going to do right now, we're going to set the memory location of server address with zeros, and we are going to flood it with zeros for the size of the server address. Simple as that. This is really easy to understand, at least this part. Now I understand that this part right here may be a little bit confusing to you, but the best practice is to search every function right here and see what they simply do. Most of them just interact with the system with different bytes or different data, so it can be a little bit confusing. Therefore, that's why this actual section is belonging to the advanced section, and not everyone will be able to understand this, at least not everyone without programming knowledge. That's why I advise you to first of all learn C and then come and follow this tutorial. It will be a lot easier for you. Memory set. Okay, so we set our memory right here, and now we're going to set the different parameters to our server address from the struct socket address underscore in. So server address dot sin underscore family to be equal to af underscore inet. Oops, not two dots, we want dot and comma, and then server addr dot sin underscore addr dot s underscore addr, and here we're going to set the inet underscore addr from this server IP, which is our variable right here. Okay, so server IP. And the last thing we need is to set the port, so server addr.sin underscore port equals htons function of this server port. Okay, so everything right here is already familiar for us. We did that in the server-side code, but we're going to leave that for the next video, where I'm going to show you how we can perform the connect function every 10 seconds. So as soon as the target runs this actual program on their PC, if we are not setting up our server immediately, then this actual program will try to connect to our server every 10 seconds. Therefore, as long as this PC is turned on, we can access it whenever we start our server. So that would be about it for this tutorial. Let me just save this, and in the next video, as I said, we're going to connect back to our Kali Linux machine and enter the shell function. Hope I see you there, and take care. Bye.